Hey guys, welcome back to Science 6.4. We are on page 150. Yesterday our main focus was on basically like heat of fusion, going from solid melting into a liquid or going from liquid into a solid. Okay, that is where heat of fusion comes in. Okay, remember that on page 145, 6.2. How much heat it takes to move it into the next one. Okay, now that it's at the melting point, etc., latent heat, the heat that's involved in that's invisible to see, but it creates your heat of fusion, right? Well, then the same thing is considered when you're evaporating and condensing something. You saw that when we started on page 148. You saw the boiling point elevation. You saw heat of vaporization. And we're going to finish that today on page 150 when we talk about condensation. Easy to understand, I believe, now that you understand yesterday's, and it's written very well here about what condensation is. So please give me three sentences on condensation, okay? I think it's very interesting. It's talking about heat of vaporization. It's involved in both evaporation and condensation. So look, so after you do your 3 sentences, look at practice 6.4. Make sure you write down the answers for 1 and 2. I don't want to do 3 and 4 because we skipped getting into the equation from specific heat way back when. We're just not going to even go down that far in depth right now, especially when we're not together, so we can't talk about it and explain some things. But you can look at number 1 and 2. It says use the tables on page 145, 149 to answer these questions. Look what it says. This is very practical. How much heat must be added to 30 grams of solid iron to melt it, assuming the iron is already at its melting point? So it already has enough heat to get to its melting point. Go to page 144. It's already at its melting point. Sorry, 145. We look at iron. The melting point for iron is 1,538 degrees Celsius. Okay, thankfully it's already there. But it's going to take 257 joules per gram to convert it, to melt it down. Okay, to actually convert it into a liquid. Okay, so what do you have to do? You have to do that number, the heat of fusion number, which is 247 times 30 to get your answer, just to let you know. Okay. Then it says in number 2, how much heat does 4 grams of acetone at 56 degrees Celsius release when it condenses? So remember that to change a solid into a liquid takes joules of energy. Remember, it takes the same amount of joules of energy to go back from a liquid to a solid, okay? One's giving it off, one's receiving it, right? The same thing with evaporation and condensation. So when they say how much heat does 4 grams of acetone at 56 degrees Celsius release when it is condensed, okay, we have to go over to page 149. We look at acetone is, the boiling point is 56, so that's why they said 56 degrees, but it says 513 joules per gram is released when it's condensed. So you have to go 4 times that 513. Okay? Vapor pressure is a little bit, look at on page 150, vapor pressure is a little bit of a confusing one, okay? I'm going to show you a quick little video. I'm not even promise I'm putting it in here, okay? I'm just going to try to remember the link, okay? Inside the group, because I'm doing horrible about that lately. Okay, so, vapor pressure, there's a video there of 1 minute and 54 seconds to kind of help you see it visually using water and how it boils, okay? Because vapor pressure is different from normal pressure. Normal pressure, if you look at, I'm just going to point this out to you so that we can avoid feeling like there's a contradiction here, because I sure thought there was one, okay? Page 150, let me find it. At higher pressure, at higher temperatures, evaporation is faster than condensation, while at lower temperatures, condensation is faster than evaporation, I think is what it is. And basically it was saying that the lower the pressure, the faster it's going to evaporate, okay? The lower the pressure, the faster it's going to evaporate. However, and you'll read that in there, however, at the very end, it's talking about vapor pressure, and it says the higher the vapor pressure indicates a greater tendency to evaporate. So you're like, wait a second, so lower pressure, easier to evaporate, higher vapor pressure, easier to evaporate. How does that make any sense? Is it low or is it high? Well, here's the thing you're going to see in the video. Basically, pressure and vapor pressure are at a battle, okay? Let's say that you have a pot of water. Let's say you have some water here, okay? And in this water, you're heating it up to boil it, right? The atmospheric pressure is pushing down, okay? Which makes it hard to boil it because it's condensing the molecules together so they can't spread out and create the gas that needs to bubble, okay? But there is a vapor pressure pushing up inside the water. They are at a battle. The pressure coming down, the vapor pressure coming up, okay? If the vapor pressure wins, you can bubble your water and boil it, okay? If the atmospheric pressure wins, you cannot. So if the vapor pressure has to become greater than atmospheric pressure in order for the boiling to start. So that's why it's lower the pressure, the less pressure there is above it, you can boil. Or the higher pressure in it, the vapor pressure, you can boil it. Okay, that's why it sounds like a contradiction, but it is not. Okay, so I want you to write 4 beautiful sentences on vapor pressure now that I'm giving you a video, and you have a couple paragraphs there. If you go to page 151 and you see all these pascals and kilopascals and all these degrees and stuff like that, don't get overwhelmed by all that. Stick with the video, stick with the first 2 paragraphs of your vapor pressure. You're going to understand it and be content. Okay? If you look at page 152, also I need you to give me 2 sentences on isobutane and how it is used in hairspray cans. Okay, isobutane and how it is used in hairspray cans or aerosol cans. Okay, and then on page 152, I want you to tell me 6 sentences on what are heat pumps and how do they work and where are they used. Okay, because they're all over the place. Good information here in refrigerators, in air conditioners, and different things like that. If you look at page 154, just give me 1 sentence in your own word about sublimation and deposition, and 2 sentences about plasma, okay? Here they give you a good little things to read, guys, to really understand a few things. Principles of refrigeration, interesting information about the characteristics of gases and liquids there. And then changes of state, just give you a really good little study guide on knowing those terms well in a few words. Okay? Just for your information there. All you need to do is the concept review on page 155. We do not need to do the application. Have any questions? I am here. If you want to know something a little bit more than just reading it, look for a YouTube video. It really, really helps you guys. It seriously does, because they give you visuals. And then there's a scientist there using the visual and explaining things using other information that they know. And it adds a lot of knowledge to your brain, which is very helpful. Bye.